Today we'll be talking about visual elements for designing data visuals. And we'll be giving a brief overview of some of the things to consider as you're designing data visuals. In particular, you'll want to consider these three things: the nature of the data, which aesthetics you're using to help for perception and cognition of your audience, and then the audience itself. So let's take a moment and think about how these elements work together. Now, data can often be thought of as spatialized when put into a visual format. By thinking about data visualization as spatialization, we can show that certain things are taller than the other if they have a bigger number. So in this case, which number is larger, 284 or 912? If we turn this into a plot, like this bar plot down at the bottom, we can see that the size of the columns help us to understand both how big the numbers are and helps us to understand the size of the difference. And so in both the comparisons of A and the comparisons of B, we can see just how much different they are, and in putting it in a visual perceptual realm. Now, this method of spatializing data is very common for data visualization, and there are many ways that you can manipulate the position, the length, the angle, and circular area and rectangular areas to help show how data are presented and communicate both the magnitude of whatever the scale is that's being used, as well as categorizations. So many people are familiar with pie chart. It uses these same principles, but uses angles instead of bars or area to show how much bigger something is. Generally, length included, we call these pre-attentive attributes. So these are the kind of surface features of an image that your eye is pretty good at picking up, and it allows you to highlight your attention to particular areas. So here are a variety of ways that this can show up. For instance, length, it's really easy to see which of these lines is longer. Width, we can see easily which line is wider. Size is often used to show the magnitude of something. You can also show changes in position, shape, curvature, add extra marks for emphasis, like in closure. You can also change color values and color hue to help emphasize attributes to particular points. Change orientation, as well as how things are grouped. And these generally are kind of the building blocks in which you encode different dimensions of your data. And generally, we can think of these in relation to another idea, which is a Gestalt principle. So to summarize Gestalt, it's basically saying a Gestalt is kind of an impression or a perception in which the sums are greater than the whole. And these are often used as part of artistic expression, but they come in handy for data visualization because they help to recognize that sometimes patterns can have more meaning or sense making if you take advantage of these Gestalt principles. So let's go through some examples of this. One that's really common in this one is closure. So even though this is really just three separate shapes, we can see that our eye wants to turn this into a G, a capital G, because our mind is already filling in the blanks. And so by using these as a way to show that perception can kind of take advantage of holes, you can use this to your advantage when designing graphics. Proximity in this case shows that even though these are all grids, your eye is still putting together an image of an E. Same with continuation. Even though there's no real bar or any reason why we think these pieces are connected, we get the impression that this is going through the S. Oftentimes, data visualizers use similarity to express that something is the same. So by repeating a pattern or color, you can help to create a gestalt that things belong together. And then there's also this for figure and ground. Notice how the A is actually looking like a tree with inside of it. And this is another pattern often used. Some of the best examples for Gestalt actually come from logos that you probably commonly see. So for instance, the logo from NBC shows some similarity. Each of the different teardrop shapes are stacked together to create an image of closure that helps us see kind of a peacock. And notice that they even cut out a little beak there to help emphasize the foreground here. Hyatt has a great example of continuation, also known as flow. So even though there's nothing really connecting this leaf to the rest of the image, it creates a sense of dynamic movement because your eye is already filling in the patterns and trying to interpret what is happening in this leaf. Here's another example of ED. You can see that the E is actually cut away, but because of the way this is closed in, our eye is already figuring out what that shape means. Adidas is another great one. You can see the proximity of these bars, keep it all together as one particular unit, as well as the way the lettering is formed. Here's one that shows the figure in foreground. Notice the cutaway of these birds, which only exists through the white space, the absence. And a Seattle favorite, this is the Starbucks logo. Notice the great use of symmetry here. As you cut down the middle, both sides are the same. You also have some great use of foreground and figure in order to create the kind of face and image within this. And some useful closure as you see there's circles within the circle. So as you'll study Gestalt principles, you'll start to pick up on their appearance more. And related to data visualization, they really become important for designing representations. So, you might have a series of images and you want to display the relationships within those. So you can do that by breaking them up into different groupings. You can add color elements as a pre-attentive attribute to show some differences among those elements. And then you can layer in things like shape and layer in size and then layer in color. And now you're starting to create really complex relationships as you've added more and more dimensions to your data. Furthermore, these can exist as kind of floating objects, but when you tie them together with a line, it now creates a sense of flow and relationship that was probably missing before. And so as you can see, even with or without the line, these data points have a much stronger pattern that's easier to interpret for your user by simply using some of these simple lines to create a sense of flow and dynamics that don't really show up as well here. It's the same data, but again, it's leveraging the perceptual nature of spatialization and that we're able to visualize. So we talked about some of these considerations in the broader sense, but now we're going to talk about some specifics around the nature of data, the aesthetics for perception and cognition, and what you should think about for your audience. So let's talk about the nature of data. Data, or datum, the singular data point, are defined as the facts and statistics collected together for reference or analysis. And in our information age, we're oftentimes bombarded with data. But it's important to recognize that its original meaning in Latin comes from something given. So data is usually given from some source. Data tends to have characteristics that allow it to be grouped and visualized, and it can be spatialized on a plane, oftentimes a Cartesian plane with XY coordinates. But also you can, translate these to globes or pie charts and things like that, which, change the way the plane is viewed. Now, data come in many different flavors. Some of the most common ones you'll see fall on a measurement scale that can be classified in these 4 areas. Nominal, which is like named categories. Ordinal, which would be ordered categories. Interval, which follow regular segmented marks along a particular scale. And ratio, which allow you to put a meaningful 0 on your number line and make comparisons and translations along a consistent number line. So we'll talk about this more in future lessons. But depending on what kind of data you're working with, it really limits the kind of operations you can do with it, how you can translate it to other types of data, what measures are appropriate for summarizing your data, and what kind of objects would make sense to use as representations for those particular measurement scales. So in this case, you can see nominal categories oftentimes look like icons. Ordinal will give you a spectrum of icons, but they're still usually separated. Interval can help you see groupings together pretty easily. And then, of course, ratio is the traditional number line with any number available to you in between those values. And while the flavors might differ about what kind of measurement scale, we can also change how we show the data. Oftentimes, we use a table to demonstrate some organization of properties, such as observations and the variables of those observations. We can also use graphs like the X and Y coordinate that you're probably familiar with from early math courses, as well as using latitude and longitude for more geography locations. And these can also be translated to kind of more nuanced ways of visualizing, such as network maps. But oftentimes there's some kind of manipulation in order to turn how similar the nodes are in a network in order to create some coordinate system for those values. So there's lots of different ways that data can kind of show up, but most of them fit together in some combination of the different measurement scales and putting them into a spatial dimension, and then layering in some pre-attentive attributes to help create a gestalt that can be easily interpreted for your user. So next I want to talk about the aesthetics for perception and cognition. So data visualization is often seen as kind of a hard science because it's related to computers and data collection. But there's actually quite a lot of artistic and creative power behind the best data visualizations. And by leveraging aesthetic choices, you can better design for your purpose. So today I want to talk about different ways that you can leverage perception and cognition. And to start, let's talk a little bit about our visual systems. So visual systems will pick up on patterns almost effortlessly. Your eye will track in ways that you might not be very conscious of. So it's important that when you're designing for a user, you think about what kind of attributes can help guide the way their eye moves and that they focus their attention on the particular things you want. And then that attention will translate to perceiving the patterns that need to be interpreted by the audience as intended by the designer. So the designer will oftentimes try to create a user experience that eliminates distractions and really focuses on trying to get that information from the page or the screen into the minds of their user. So let's take a brief look at what the visual system looks like. Most watching this video will probably have eyes in order to interpret the images that they're seeing. And there is also important ways that we can bring data to those with low vision or no vision, which we'll talk about later in this course. But for the most part, the visual system works around having binocular vision, meaning two eyes. And you have these overlapping fields of view that allow you to take in light, which then passes through your lens and hits the photosensitive region in your eye called a retina. So these photons hit your retina and they'll activate specialized cells in the back that pick up on light. And these are commonly known as rods and cones. And they're called photoreceptors because they take activated signal from the light hitting the molecules inside the cones and rods and turn it into an electrochemical signal. And so that creates the pathway along your nervous system that allows the information to travel from your eye into other parts of your brain where it is processed. So after the rods and cones are activated, the signal then passes to other parts of the brain where it begins to be processed. And this is where the noise gets cut out of the signal, and you begin to fill in those blank patterns that help us perceive the world around us. Now, light exists on a spectrum based upon the wavelength of the light. They'll have different energies. And so your eye is adapted to pick up on these different energies. So for instance, blue light will activate the blue cones. Cones will be responsible for different colors. We have red cones, blue cones, and green cones. And by combining them, we can see the full spectrum of the visible light spectrum, and going from violet all the way to red. Rods, on the other hand, are more equipped for light versus dark distinctions, and they're most useful in dark environments where color isn't very apparent. So by combining all of these photoreceptors, we can see that in blue light conditions, we'll mostly have the blue cones lit up. In red light conditions, you'll get some of the red cones, but not really any of the others. And by focusing on which of the combinations are visible, your brain is able to interpret what color it's seeing. So there are very particular wavelengths that these cones are optimally going to fire at, but in reality, it's a concert of the different molecules reacting within the eye's retina that allow you to interpret an image. And so with light being on a spectrum, it's important to think about how to design colors that will fit with the way that users view things. Now, in elementary school, you probably learned about the color wheel. And in actuality, there's kind of two ways that you can think about these color wheels commonly. The traditional way that you probably learned in elementary school was how you kind of mix paints and pigments in order to subtract colors by combination. So when we mix red and blue, we get kind of a purple color or violet. When we mix red and yellow, we get more of an orange. This is oftentimes how we teach colors in art class because the pigments help to blend these together, and by subtracting colors, you actually get the combinations. Now, when you're not working with pigments, when you're working with the creation of light, which is what happens on a computer screen, we're going to use the RGB color wheel. This is the red, green, and blue. So if I take red light and I shine blue light at the same space, I actually get magenta, not violet. And that's because they have an additive effect in these kind of color wheels. So you're not taking away light like you would in the other options. You're actually combining them together and adding them. So red and green also make yellow, and green and blue make cyan. And between the combination of lining up red, green, and blue on your screen through pixels, you'll probably be able to get all of these different colors in some combination. And to kind of highlight this fact, let's look at an image of an LED screen zoomed in really close. Now, you'll probably see here that the R stands out as only firing the red pixels, the green stands out only firing the green pixels, and the blue stands out by only firing the blue. But the background of these three letters is actually white. And as you can see zoomed in, it actually has the combination of all three of those diodes which produce the light. So most of the images you see on the screen are really just a combination of these three colors. And when we're designing graphics, we have to know what kind of combinations of colors work well together, which ones are too close that they don't create a discernible distinction for viewers. And more importantly, we have to be aware that people experience vision differently, and things like color blindness, or also known as color vision impairment, prevent patterns from being detected in a way that somebody with a full spectrum of visibility would have. So let's look and see what a retina of someone with color vision impairment looks like. So these have been artificially stained to represent the back of the retina. Each of these dots would represent a photoreceptor. As you can see, somebody with all of their cones would be able to pick up on red, green, and blues and this kind of mosaic pattern in which different parts of the image would be sensitive. So light would come in, hit the back of the retina, activate this, and it would create a cascade of signals. Now, notice that this one on the right, the red-green color blindness, has no red sensitive photoreceptors, and therefore all of these would be green. So anything that would show up red would actually look green in this case, which is why it can be really hard to distinguish those colors for people with color vision impairment. So that's something to be aware of when you're picking colors. Maybe you don't want to use red and green as contrasts, since a sizable portion of the population has color blindness. Now, another way that your eyes kind of play tricks on you is by filling in blanks. So I'm going to show you another image, and if you have photosensitivity to patterns, you might want to look away for this next part. Okay, so this is called the Hermann effect, and notice that there are dark squares, and each of these dark squares is bordered by a white grid. Now, as you look at it, you'll notice that the portion where your eye looks is pretty clear, but on the corners of it, you'll see that the grid is actually filling in some gray dots where there should be an intersection of the grid lines. So for instance, if I'm looking over here, I can tell out of the corner of my eye there's like little gray dots appearing in these spots. But they disappear as soon as I look at them. This is an illusion that's created by your eye trying to fill in the blanks and interpreting light and dark spaces and boundaries, but not being able to easily process that information between what is noise and what is a strong signal. So illusions are a big part of how your visual system works. And by understanding these kind of effects, you can avoid creating things that might seem distasteful because they create these distracting illusions. But also you can improve the way that you make images stand out so that the signal is much clearer. Another way that people use visual aesthetics is by using color schemes to signify how things are related. Now, you'll see here different orders of the color schemes that are commonly used. Sometimes it's grayscale where there's an absence of color, just different shades of gray are being used. Sometimes it's blue to gray. Sometimes you'll use some sequential terrain. So for instance, you might see on a map that mountains are darker green, whereas farmland might be a lighter green, and then urban areas might be more of a desert sand color. You also have divergent color schemes too, where maybe a blue is more positive and a red is more negative. And then also unordered hues, which help to show categories most commonly that are not related, but are distinct on their own. So we'll have some experience working with these groupings, and we'll also have an opportunity to learn about one that has kind of turned some heads. This is Ed Hawkins' Show Your Stripes image, and this one uses divergent color scheme to show how temperatures have changed around the globe over the last decades as climate change has affected areas differently. So next, I want to talk about some things to consider for your audience. No visual exists on its own. You always have to have some kind of audience member for your data visualization to be interpreted and useful. So think about who your audience is as you're presenting. And we're going to talk about a few considerations that you should focus on as you design. So the first thing is cognitive load. So people have a working memory to keep short-term memory together and interpret what you're looking at, but it's usually limited to 5 to 9 chunks of information at a time. So a chunk could be something like a birthday or a phone number, but the point is that we are very limited in how well we can take in that information. And it can quickly be overwhelmed if you're looking at an image for the first time. Now, experts have been known to process information more effectively because they can see patterns within patterns. And so instead of focusing on 5 to 9 chunks, they've already chunked those information into smaller bits. So until you've developed kind of a data visual literacy that's at an expert level, most of the time you're going to be trying to work with smaller parts and designing those for people who might not have much experience. So the important thing is to use those pre-attentive features to kind of reduce the information and use them consistently. So if red means one thing in one particular part of your image, make sure that it stays with that same meaning throughout. This will help reduce the overload that people feel when they see a very busy graph. And in particular, as novices, you'll try to show all of the data at once, and that can actually go against what good data visualization design looks like, because it distracts people and they're not able to glean at a glance what the pattern is. So this brings me to my next point. People's attention is limited. You want to be able to engage your audience quickly and in a way that they know exactly what they're looking for as they pass through the information. So just like foragers in our early development of humanity were able to find kind of fruits based upon bright colors, people forage for information in the same way. If it's easy to do so, they'll take time to gather that information. But if it's too burdensome, like the blackberries that are entangled in thorns, they're just going to pass on and move on for the information that they can easily gather. So think about how you can leverage people's attention by leveraging things that are familiar to them, using call-out titles that are easy for them to see and interpret. Oftentimes we can include the findings. And then also take advantage of the gestalts that we already use in our day-to-day life. So if you're an English reader, you probably spend a lot of time moving your eyes from left to right. And to be consistent with that movement, you should design your graphics in the way that they move from left to right. So thinking about how to order your categories can help if you have large things in the left and small things on the right. We'll look at more examples of this, but the idea is that your audience already has some patterns that they're going to pick up on before they even get to your visual. And so using those so that they can interpret the information quickly is quite useful. And one last thing that you'll really need to pay attention to is accessibility. People really favor things that are easy to use and easy to understand. And good design is going to make those interactions as painless as possible. So if there's too much burden, if there's too many noisy parts to your graphic, your audience is going to turn off, shut down, their mind will avoid it. So you want to make sure to invite people into your image and create a simple narrative that can allow people to glean information from it. Also consider limitations for color. So people with low vision or color vision impairment will oftentimes be confused if you layer in things that depend on subtleties of hue or subtleties of contrast, or simply are too busy. So when you're designing graphics, always use kind of the alt text to describe what your pattern is showing as you're designing your visual. You can embed that in the image or the graph itself. But also try to avoid situations where there is ambiguity for somebody who might not be able to distinguish red and green.